Now you clearly understand what is a rotating magnetic field. When you apply AC voltage, definitely the flux are also 120 degrees apart. Those are traveling. Alright, now when AC voltage is applied to the stator, the poles are excited, it will develop the flux. Flux also rotated by 120 degrees apart. So this is, we can call it as a rotating magnetic field. Okay, rotating magnetic field is generated. Now this rotating magnetic field is enter into the rotor. In rotor what you have? You have a conductor. So what is the speed of a rotor? N. The speed of a rotor is ఇంకా నాకు rotor rotate కాల. The speed of rotor is 0. There is a relative motion between the stator and the rotor. The stator speed, rotating magnetic field speed is nothing but synchronous speed, ns. Now the rotating magnetic field enter into the rotor. So rotor which is having a conductor. Now rotating magnetic field, because the relative motion, rotating magnetic field also rotate around the conductor. According to the Faraday's law of electromagnetic induction, change in flux is produced now. Field is rotating and conductor is stationary. Definitely the voltage will be produced in a conductor. Thereby current flows through the conductor. So in conductor, current will be produced. Now we'll see the magic. When current flows through the conductor, there will be a field around the conductor. Na? So when, you know the motor principle, when current carrying conductor placed in a magnetic field, rotating magnetic field, definitely there will be a force. Due to that force, the torque will be produced. Due to the torque, the conductor starts rotating. I think you people understand the logic. Same motor logic, because the flux, conductor flux is there, rotating magnetic field flux is there. Alright, you know the motor action. When current carrying conductor placed in a magnetic field, it experiences the force. Due to that force, my conductor starts moving. Right? That's why we are converting electrical energy into mechanical energy. One second, I'll explain. I have a stator and I have a rotor. Stator which is having a poles. When three-phase AC supply is given to the stator, what happened? A rotating magnetic field will be developed. What is the speed of a rotating magnetic field? ns. What is this? How the rotating magnetic field will be developed? You have seen in a figure, right? So rotating magnetic field enters into the rotor. In rotor, what you have? A conductor. Alright? Is there definitely there will be a relative motion between the rotor speed and the stator speed. What is the stator speed? ns. What is the rotor speed? n. That is equal to 0. ns minus 0. Definitely the speed is there. ns. With that speed, rotor lo rotating magnetic field rotate అవుతా ఉంటుంది. Right? When rotor lo rotating magnetic field rotate అవుతా ఉంటే, you know the Faraday's law. What the Faraday's law? Field is changing. Definitely there will be a change in flux around the conductor. Change in flux produces the EMF in a conductor. Right? Due to that EMF, there will be a current flow through the conductor. See the motor action. When current carrying conductor placed in a magnetic field, definitely what happened? The force will be created. Due to that force, torque will be created. Due to the torque, my rotor starts rotating with a speed of n. Per suppose along the direction of the synchronous speed. Per suppose with the help of external force, if you rotate your rotor into the synchronous speed, rotate చేసావు, definitely what happened? Is there any relative motion between the stator and the rotor? Stator speed is ns, rotor speed also synchronous. If you think rotor speed also synchronous speed, so what is the relative motion? ns minus ns. The speed is 0. If there is no speed, so conductor is stationary. Rotating magnetic field, relative motion also 0, because ns minus ns 0. There is no voltage, there is no current. If there is no current, there is no rotation. That's why in induction motor, the speed of a rotating magnetic field will be very high when compared to the rotor speed. So in induction machines, you will see what is the slip. The difference between stator speed and a rotor speed, we can call it as a slip. What is the percentage of slip? ns minus NR by NS. You will see what is the slip at the time of starting. At the time of starting, is there any rotor rotation? No. At the time of starting, rotating magnetic field will be developed, but that rotating magnetic field enters into the rotor, then the current will be produced. Due to that current, field will be generated. Current carrying conductor placed in a magnetic field, it experiences the force. The conductor starts rotating. So at the time of starting, there is no speed of a rotor. What is the slip value? S is equal to 1 at the time of starting. So those are the points, the torque equation and all the starting torque, running torque, full load torque, torque versus speed characteristic. These are not the basics. You have to go through the subject and you will clearly. This is not the time to discuss about all this information because I am dealing a power system here. So some of the persons asked me to explain each and every machine simple manner. That's why I am taking these classes. Alright, how induction motor will work, you clearly understand, right? So just better to understand the rotating magnetic, how the rotating magnetic field develop. Definitely will grab all the subject. So what is a slip? Slip is nothing but the difference between the stator speed and the rotor speed. We can call it as a slip. Right? Is there any difficulties? You can call me, right? Simple. That's how induction motor work. If you know the motor working, definitely you will grab from that only the induction motor will work. How the induction motor will work will come that principle only. After that, we'll go for a synchronous generator, alternator. Alternator is nothing but induction generator. How induction generator will work, you will see. So it is an induction generator. A generator which converts mechanical energy into electrical energy. So mechanical means rotation. Alright? So rotation, definitely rotation will be in a rotor side. This is also having a stator and the rotor. You are giving your mechanical energy in the rotor. A rotor lo నాకు ఇప్పుడు ఏమున్నాయి magnets. Alright? So when mechanical energy is given to the rotor starts rotating. Magnets are tightly in the slots. Those are rotating. Is there any flux will be developed? We'll see. When mechanical energy is given to the rotor, flux will be developed. This flux is sufficient to develop the voltage? No. So we need to energize the magnet. So you don't have any electrical supply. You are giving a rotation, just you don't have a sufficient flux to generate that much three-phase voltage. So for this, we need to energize the magnet. So with the help of a DC supply. So unless if you operate a DC supply, only the alternator will work. That's why the alternator is not a self-started. Right? So if you give a mechanical energy to the rotor lo magnets untai. Magnets are excited by the DC supply. When rotor starts rotating, the flux will be developed. The flux also rotating. Rotating magnetic field will be developed. So what is the speed of rotating magnetic field? Speed of rotating magnetic field, synchronous speed. Okay, synchronous speed developed. ఇది కామ్గా ఉంటుందా? Then it will enter into the stator. స్టేటర్లో నాకేమున్నాయి? కండక్టర్స్ is there. When conductor, rotating magnetic field around the conductor, what happened? According to the Ampere's law, the current will flow through the conductor, thereby the voltage will be produced in the stator. I think clearly understand. See, in alternator also you have a stator and the rotor which is having a rotating parts. So you're giving a mechanical energy to the rotor because the stator is a stationary part. Rotor lo mechanical energy icha. Rotor lo నాకు ఏమున్నాయి? Magnets ఉన్నాయి. Magnets are going to be strictly rotated, right, giving a mechanical energy, but there is no sufficient flux until unless you should give the excitation, only more number of flux is going to be generated, that much EMF is going to be taken out from the stator. So for this we need to excite a magnet. So magnets are going to be excited by the DC supply in a rotor. Then only the rotating magnetic field will be developed. Okay, rotating magnetic field will be developed. After that, rotating magnetic field enter into the stator. In a stator, what you have? In a stator, you have a conductors, right? Magnetic field around it. The conductor placed in a magnetic field, what happened? The current will flow through the conductor according to the Ampere's law. So that current will come out from the stator itself. That's how the alternator working. You see the alternator. Which speed is higher? You are giving a rotor speed, right? You are giving us mechanical energy. First rotation ekkada jarugutundi? Rotor lo. So the rotor speed is higher, right? When the rotor speed is higher in R when compared to the stator speed, right? Stator speed is ns. So nr is greater than the ns. We can call it as a induction generator or alternator. So definitely in a idle, thermal, all the plants you are getting a mechanical energy, so that can be converted into the electrical energy with the help of alternator itself. Thank you guys. If you have any problems, if you have any doubts regarding electrical machines like generator, motor, you people all you know my mobile number. You just call me and definitely I'll give. This is for a little brief introduction how the electrical machines will work, and we don't have a time because we need to start power system. So that's why we'll start power system lectures. We'll continue from other classes. Alright, thank you guys. Stay home, stay safe, make your surroundings also safe, prepare your videos, just see the videos. Definitely will get information regarding how generator will work, how motor will work, and how induction machines will work, and how alternator will work, why alternator is not a self-started. Alright, so all these things you will get clearly understand. Just basic information. If you are electrical engineer, right? As per my knowledge, nowadays the people's coming out from electrical department, they don't have even the basic things. What is the Faraday's law? What is Lenz's law? What is Ampere's law? And all these things. Definitely, they'll get difficulties when anyone asks. If anyone asks about how generator working, how the motor working, from these videos, you will definitely explain the basic minimum. Explain with minimum knowledge. Generator. So this type of this is the way the generator will work. The motor will work. This is the way generator, the synchronous alternator will work. Induction motor will work. All these things will clearly explain. Just remind the videos and see the videos at least once for my happiness. Right? And thank you very much. Stay home. Stay safe. Goodbye. Bye guys.